Or let me set the context for the video. In this video, we have Joe from Drip. Drip is an application on Solana that airdrops a lot of compressed NFTs. They were one of the first companies to use the compressed NFT standard. We'll understand their journey of pivoting from an offline only model. They were earlier at a different company called Solana Spaces that did a bunch of offline spaces on Solana. Eventually, they pivoted to a purely digital product that's heavily related to NFTs. So we'll understand how did this pivot happen, what is their backend in, and surprisingly, their backend is written in Elixir, which you wouldn't hear a lot of Web3 companies do that. Why they made that choice, the architecture is very different from how you would expect a normal app to work, and the challenges that they're facing currently. Challenges also lead to bounties. Since their backend is in Elixir, and Elixir isn't a language commonly used across the Solana ecosystem, we don't have a lot of good Elixir clients to interact with contracts. We have TypeScript and Rust clients usually. Usually, when someone deploys a contract, they write TypeScript and Rust clients for it. Rarely will you find someone write an Elixir contract. So the bounty for today for $1,000 is building native implemented functions in Elixir. What is an if? Think of it like you being able to call a Rust function under the hood using the Elixir language. Right now, if you go through the podcast, you'll see they do something very similar, but with TypeScript. Even though their backend is in Elixir, they're somehow using the TypeScript client to interact with the contract. The goal of the bounty is not really to build a client in Elixir from scratch, but to use the Rust SDK for this specific contract and build native implemented functions in Elixir so that for the folks at Drip or other people who want to interact with that contract, they can easily do it using an Elixir client rather than depending on TypeScript or Rust. The specific program that we're talking about here is the Metaplex Bubblegum program. I know it's a weird name, but most Metaplex NFT standards are named this way. You might have heard of Candy Machine in the past. It's a contract deployed on the Solana blockchain, and you have to write an Elixir client that under the hood is calling the Rust client to interact with the contract. I hope to see a few submissions on the bounty. It's linked in the description. And for everyone else, let's get into the podcast. So let's kick things off with the Solana Spaces journey. Is there anything like very technical in there or very difficult to implement as an engineer, or was that fairly simple to navigate?
Yeah, so Solana Spaces a little bit.
Was it like a major change in terms of all the technology things that you were doing? Because it's one thing to be a physical first business, and then you have to move to a primarily a digital first product, right?
Yeah, it's really tough to say. I think it's more of.
I'm curious to learn more about. Did you have to go through any kind of shift in terms of your thinking to actually architect around these constraints?
I'd say the biggest one is just really built.
That's the first time I'm hearing that architecture. Is this called something like getting rid of REST all across and just focusing on WebSockets and having in-memory data? Have you used this somewhere in the past? Is there a reason you architected it this way?
I mean, we definitely have used like
Hello. Welcome everyone to the OnlyDevs Podcast. Today we have with us Joe, the CTO of Drip Haus. If you're in the Solana ecosystem, Drip Haus is one of the leading consumer crypto products in Solana and of course all of crypto. So excited and happy to have you here, Joe.
Thanks for having me. Excited to be here.
Cool. Maybe let's kick things off with your journey, Joe. When did you get into coding a little bit? Do you work in the Solana ecosystem before Drip? And how long have you been working in Web3?
Yeah, so it goes back quite a ways, 15 years plus engineering in general, all the way back to, people probably remember MySpace, and then a few startups since then, eventually at Beta, and then Solana Spaces, which then led into Drip. So it's been a pretty interesting journey. As far as Solana, definitely Solana Spaces was my first kind of introduction into the Web3 side of things.
Got it. And Solana Spaces was the initial company that started that eventually sort of pivoted to Drip, which is what you're currently working on, right?
Right, exactly. At the tail end of Solana Spaces, we really kind of found, something with the Drip concept, and it started taking off. And this was pre-compression, and the model was airdrops. And, that kind of, we hit a interesting point there toward when compression became available, where it was getting really scary in terms of the costs associated with what we were doing. So that was the timing of compression was pretty important for us.
Got it. So let's take things off with the Solana Spaces run. Is there anything like very technical in there or very difficult to implement as an engineer, or was that fairly simple to navigate?
On the compression side?
No, way before that, like when you started Solana Spaces, and maybe even more context. What was Solana Spaces?
Yeah, so Solana Spaces is a little bit different, more of a retail concept. So we're talking about more kind of like back office type, inventory management systems, tutorial systems that we did some kind of innovative things around in-store tutorials that connect to devices, like kind of like iPads in the store, where somebody could go through them. So we had a lot of interesting technology, but very different from the stuff we're working on now. So we'd have kind of like WebSocket connections between all the devices and be able to kind of centrally manage them and run different tutorials and track everything. So very interesting problems, just quite different.
Yeah, I remember visiting Solana Spaces in New York like back in 2022. It was it was much more than a retail space. It was like there was a lot of technology all around you, and for anyone who just walks into this shop in a posh mall, they're thinking, hey, is this like a design brand or whatever that hooks them in? And it was so surprising and also very, very cool to see all different sort of tutorials you could use. You could in fact go set up your first Phantom wallet. You could get discounts if you pay with USDC and so on. What led to, was it like a major change in terms of all the technology things that you were doing? Because it's one thing to be a physical first business, and then you have to move to a primarily a digital first product, right? So how did things change internally? Did it mean that you had to become like an engineering first org, or would love to hear you talk about the transition there?
Yeah. It's really tough to say. I think it's more of just the aspect that we saw really kind of take off out of everything. And I'm sure just the general overhead and costs associated with a retail business are far different than a non-retail business. So I'm sure that's a big part of it. And then when you see the kind of momentum really catching around something, you kind of just say we need to maybe put more or all of our efforts toward this direction.
Got it. That makes a lot of sense. So in this transition of moving to building something like Drip, I would assume back then you were just minting NFTs, without any compression. So could you talk through the very first version of Drip that was made, the very first drop that was done, the challenges that you saw there?
Oh yeah. We went through quite a series of different styles and challenges. So the earliest days of it were just really one by one. And I think since the beginning, pretty much since the beginning, we did have a good concept of the necessity of robustness and ensuring that if we're starting a job to mint something to someone, we need to follow that through and account for all the failures that can go along the way. But in the earliest days, that was incredibly slow. So I can't remember exactly how large our first ever airdrop was, probably 1,000 or something. But that probably took the better part of a day because we'd kind of serially go through them mint one, make sure it worked correctly. At the time also with the metadata, we were, going through as part of that process, like serially creating that metadata per mint. And, at the end of the day, those probably cost a decent piece, each. So as things evolved, we, even prior to compression, we switched over, started using cross mint to mint to traditional NFTs at the time. And that definitely, we built systems around that for the same kind of robustness, follow a job through from start to finish, ensure that it went correctly, ensure that anything that failed gets redone and we're not duplicating any mints. When compression landed, then things really started to pick up. There weren't things already out there for it, right? So we really took it kind of on internally and said, okay, we need to now bring this kind of all in-house essentially to how we're going to do this. So we built our own systems around those mints. And at the time also back then, we were doing true, all at once airdrops, right? So 500,000, just as fast as possible. That worked really well back in I think it was kind of mid 2023. We were doing well. I think it's, largely because there wasn't as much contention for, doing things on chain as there became, but we could get those out. I think we could do 100,000 an hour if memory serves. That quickly became a problem. I think it was, not sure the exact timing of it. It might've been around March of 2024 when things got, really contentious with the network and everything. And then we moved more to a model of the user has to essentially crank, right? So if the user clicks, we mint, but we don't mint until that happens, which is good for a number of reasons. One is if the user isn't actually interested, then why do the work? Why spend the money to do the mint? But also, even if we were to automate it more, the user being involved provides a natural pace to everything, so that you can't just, you could just pace it out programmatically, but then you're not really getting that jitter involved in the send. So it's actually really nice to have that natural aspect to it. And along with that, all the aspects our minting system, we had to work through a lot of configuration around the rate limiting we're imposing upon ourselves, because well, we have no problem sending out 100,000, 200,000 an hour. The network definitely has a problem with it, and so we had to kind of fiddle with those numbers and what would make it. Also the priority fees and all that stuff that came along, figuring out how that worked. So yeah, it's been interesting, but as it stands now, the mint system is just extremely robust at this point.
You mentioned the network, etc. Right? I think it touches upon an important aspect of building in Web3 versus other traditional Web 2, mainly because if you were to treat Solana as your main database, it's the main database which is also multi-tenant and that's not part of your core infrastructure. So you don't really have any control over what kind of throughput that you can get out of the system, and you don't really have the root access to the knobs to tune the system, right? So it's coming from a traditional Web 2 engineering background, moving to working with systems where you can't really tune the knobs. What was I'm curious to learn more about how you approached this, and what was the internal. Did you have to go through any kind of shift in terms of your thinking to actually architect around these constraints?
I'd say the biggest one is just really thinking about robustness, like from the beginning. Also, maybe something that's a little bit different is that because we are airdropping everything. We don't have anybody sign for anything, right? We're doing the entire thing end to end. Like in a lot of cases, if you aren't doing that, you have it's up to essentially the user to retry their transaction or the user to follow through. In our case, like we're the user every single mint, right? So that just understanding that speed is the goal, but speed is like achieved by being extremely robust, like and highly concurrent, not like per necessarily like how fast can I get this single one through, but how fast can I make sure all of them successfully get through. So that, yeah, and having the ability to, ensure that happens was pretty important.
Interesting. Would you mind talking a little bit more about like what your internal, what these systems look like?
Sure. Yeah. So yeah, Drip runs Elixir. We run Elixir we deploy it on Kubernetes. It's backed by essentially a Postgres database. We're currently running AlloyDB in Google Cloud. Pretty high CPU instance of it, 64 CPU instance with like 512 gigs of RAM. So it's definitely it served us really well, but essentially in the beginning, it started out more as the thought of like over provisioning and being sure that it was capable, which it has been. Now essentially we're more in the kind of making up for being able to get away with a lot of things because of that over provisioning and trying to work it back the other direction and make it more efficient at a smaller scale, which would be just using the resources better. So yeah, Elixir's been really important for us, kind of like one of our secret weapons. Just in terms of its robustness in general, the things you don't have to concern yourself as much with that you may in other spaces. So like that's just been a nice thing to be able to rely on. The job queuing itself is also Postgres backed. So we use, particularly in our ecosystem in Elixir, in a library called Oban, which uses Postgres for the jobs. And, that's an interesting thing because you would think it could be potentially slower or a problem, but I mean, it's just been absolutely incredible. So they've done great work on that.
Wow. Elixir is an interesting choice. Like, were you all Erlang programmers like before, or like how did you choose? How did you guys choose Elixir?
Well, it's something I've been doing since probably around 2018 or so. We started with it, I'm pretty sure, in at Solana Spaces as well. I brought another engineer in. Even back then, during Solana Spaces, Rabiga, who basically picked up Erlang, and not Erlang, but Elixir specifically. Yeah, she's been excellent at it. Picked it up really easy. So it's definitely something that can be done. It's not a hard language. It's it's actually very simple if you think about it, because you're kind of dealing more with modules and functions rather than like classes and methods and inheritance and all these other things. So it starts to let you think about more like input output simplicity.
Yeah, and also I think the underlying the actor model itself kind of lends itself to all the problems that you spoke about, right? In terms of making sure that you execute things concurrently, and you want to have this insane robustness towards making sure everything happens. So was that like a deliberate choice towards picking this, or that was like a side effect of the choice that you guys made?
I mean, I think it's one of the things we're just thankful to have, because of Elixir, because of the Beam. And we probably take it for granted to some degree because it's just something we're used to at this point. I think, I can say that like one thing we do think about a lot is like that actual minting side, like where we're creating instructions for mints, like that part's not in Elixir. So to create the instructions that we're actually going to send as transactions, we kind of wrote a little bit of a microservice in Node.js, which we call Midgard, which just lets us from Elixir kick out and do things that are very easy to do with like a node library, and then kind of pass it back to us. And then we kick it back out and execute the transaction. So there is room for optimization because like one thing I've been thinking about a lot recently is it seems like a lot of inefficiency to me to have to kick out. And Elixir itself has a very nice and tight like Rust interoperability way you can go, where a lot of these things under the hood, even though we're using a node microservice, like those things are really based on a Rust library, essentially, right? That they're mimicking. So if we can just cut out the middleman and kind of work directly with the Rust libraries from Elixir, I think that would be a humongous performance optimization for us.
Very cool. So you're saying Solana doesn't have any official SDKs for Elixir yet?
I actually haven't checked recently. I should. We've pretty much, the thing with our system is because it is constantly churning out mints, like, it's just very stable, and that certain aspects are very stable. Moving certain pieces gets a little bit tricky and risky. So there's definitely areas we could explore that maybe things have changed since, but there's also hasn't been much reason to because it works so well right now.
That makes sense. So I'm looking at the library that you mentioned, Oban. I'm assuming this takes care of all the retries and failed transactions, so you don't have to and spend a lot of time writing a lot of retry logic, and this is all Web2 stuff. Like after that, you create the transaction and forward it to an RPC. Is that right?
Yeah. One of the things we started from day one was essentially recording the transaction hash before we ever send the transaction, right? And we're persisting that. Then we're trying it. Then what we do is we have webhooks from Helios that tell us if it completed. If those don't fire, what happened? You got to plan for all failure scenarios, right? So if that doesn't happen, then we're looking at essentially like the block valid block height. If that's we start querying for things that we haven't received notification on past their allowed lifetime, essentially. And then if we go through those and we manually check them ourselves, which I kind of call like the slow route. Like if it goes down the slow route, it can happen, especially when we've seen like the seasons of like these massive numbers of lost transactions, like there were periods of time within the last like 12 months where we probably get like 5% of what we were sending through, which was much harder. So a lot of things going down the slow route. But yeah, then once you get to the end of that, if at the end you have no mint out of it, the transaction's considered lost. We don't really have fail. Like fail isn't really something we've ever run into unless we've made a silly mistake that we've corrected. But mostly it's lost transactions that we've experienced. And then we just go through the process again. We generate a new instruction set, transaction hash, update, what we're checking, and just start over.
Very cool. This architecture sounds very similar to how withdrawals happen in a few exchanges to avoid double spending and double withdrawals. Very cool.
So one thing that I'm curious about is like after post compression, did you guys have to like run your own instance of DAS, or is that like the RPC provider takes care of that for you? Because that feels like a major compared to pre-compression to post-compression. That's a new infrastructure component that got added, and it's a major lift in terms of the infrastructure that one needs to maintain to be able to serve NFTs and make sure the state is correct, right? So do you guys run DAS on your own? They would love to hear you talk more about that.
Yeah, we've never run DAS. We've always used Helios for DAS, which has been excellent for a very long time, up until actually just the last couple of weeks. What we would do for serving users' vaults, which we call like their vault, like essentially things you own or things you could own, you could secure. And we would periodically fetch from DAS all of the users' collectibles. And another kind of tricky aspect to what we're doing is for many Drip users, the vast majority of things they have are Drip based NFTs. The problem is some of them, right, it's hard. Most are. So for us, what we learned is it makes sense to actually go and take a wallet and just grab all of that user's NFTs and then filter out the ones that aren't Drip, because the other way, trying to go through each of our collections is, very hit or miss. Like we have thousands of collections, and if we have to go ask 1,000 times per user, what do they have of this collection? The hit ratio is not there, right? So for a very long time, we were just grabbing the entire user's NFTs and then holding it essentially in our own blob cache, which was extremely inefficient. And we had to periodically refresh it rather than being essentially real time. What we've been up to and kind of done more recently is now we finally have the data set on our side of the proper current owner of everything and when they received it, when they became the owner of it at. So we're actually avoiding DAS for most vault activities now, which is a big win because there's no more periodic caching, and it's essentially instant. So that's been a pretty nice thing, and that's we're doing that by following the simple hash Kafka topics.
It's awesome. Looks like I think this one thing that's worth touching upon here is like these are complex, and these are engineering decisions that you have to make, right? For example, when you're rolling out compression, this significantly changes what your product does and also how you serve data. Now, it would be great to hear you talk about how you actually make this engineering decision, because oftentimes in startups, you literally have to kind of roll and run with the punches because things just move so quickly. So it would be great to hear you talk about, how you make these decisions, the culture that is there internally.
Yeah, I mean, on a just a bigger picture aspect of it, we just have a great team of people. So usually we're just throwing ideas around, talking things through, and we have a lot of experience on the team, which means our gut instinct a lot of time gets us pretty close and off to a great start. And on the engineering side, we can cut through a lot of the maybe like initial proof of concept phases because probably one of us, at least on the team, has dealt with a very similar problem that they can relate to the one we're working on and can get us pretty close to a solution right off the bat. And then what we do is just iterate from there. So, once something's out, we just kind of see how it's going. Every time we do something, new problems pop up. You can especially think about that related to like Sybil related things. New problems will pop up very quickly anytime you make changes there. So, I'd say that's generally our strategy is just kind of rely on our experience and get a good head start and then fine tune.
Yeah, on the note of Sybil is this game of whack-a-mole, right? It's like there is no perfect solution to this, and you would have had to deal with it. Like even pre-compression, probably it was a lot more worse because people have much more, egregious behavior of actually burning the NFTs and collecting the soul out of it. At small scale, it doesn't make sense. But then if you're sponsoring all of those things, then that means that it actually burns a hole in your pocket, right? So from that to now compression, I'm pretty sure people are kind of speculating that since it is crypto, there might be a token or there might be some incentive to go ahead and for one person to act like 100 or 1,000, right? So how do you deal with like these two stages represent different scale and different behaviors, and also also looks like different in terms of scale of the Sybil attacks you would have to deal with, right?
Yeah, it's been quite an evolution of things we've gone through with that. So we definitely started off trying to like plug holes essentially and kind of like react to problems we saw. We kind of moved into a period of proactive handling where we implemented things like Cloudflare's turnstile, which is essentially an invisible CAPTCHA. We've just gone through so many different iterations of it. I think where I, more and more just come down on it these days is that it really kind of, if you nail the economic part of it, that solves a lot of the problem. It's when you haven't thought through the economics that you're really open to the attacks.
Could you elaborate on what you mean by the economics here?
Yeah, so if there's zero cost essentially for the user to exploit something, and then they realize they can fire up 1,000 of these accounts or more, and then they can do it at scale, right? So if there's an economic cost, even if it's small, as long as it's built in, it creates that like roadblock to them to really have to think about like, is this actually going to be worth it? Because they have to put skin in the game. And there still is potentially in some cases where there is an economic aspect, but it's small enough where if they feel like they can super scale their attack vector, maybe there still is a benefit, but it becomes more and more questionable. Also, kind of some of the things that we've done that are like, I would put in like more of like an unpredictability kind of category of going and like mass banning a bunch of users that we found to be doing something wrong. That that might make somebody's day, somebody have a pretty bad day, and it might make somebody think twice about if their economic decision was the right one or not. So yeah, just I guess there's no 100% answer to it other than you've got to tackle it from like every angle possible.
Makes sense. So I saw that you guys that there is a Drip app. Could you talk a little bit more about the Drip app and how that changed the Drip mobile app?
Yeah, I don't work on the mobile app specifically, but yeah, I do use it. I like it. It's gotten really good usage lately, which is really nice to see. It's just a nice thing to be able to have like such a native interface. It's feeling very quick. So I think a lot of things are getting worked out there.
Does it mean that, and does it change like the number of users and scale that you have to operate in? Because majority of your existing crypto traffic is, you have the crypto internet, the crypto Twitter, and then you have rest of the world. Like crypto Twitter kind of lives on Twitter, and they are glued to their shares. They are on a desktop or a laptop. Whereas, that's probably the starting demographic, right? Like when you move away from that towards like primarily a mobile first experience, that also means that so net new set of users. So I'm just curious to learn more about like what it means for the your systems internally and what it means for like scale, etc.
Sure. I think what we see right now with it is that the retention is amazing with the mobile app. I think the problem with it right now is that it's a internal like test flight only thing. So I think what you're getting at is, would you see a takeoff with the mobile app? And I think the answer is probably yes, but it would have to be out there available to people, in the normal ways they would grab an app. Based on what we're seeing right now, though, with the hurdles in place just to get it, I'd say that it's probably a good sign that it would do very well.
Yeah, the reason I'm asking this is it depends on the type of experience you have, right? For example, if you were to stitch a timeline, that in a mobile product experience, people are used to scrolling through things. It means that you have to prefetch a lot of these things and stitch a timeline. So when you have many of these users requesting, is that similar to the product experience you have on web, or when it goes to mobile, does it change things significantly?
Yeah, no, I understand. Yeah. So we use the same API, web and mobile. They both actually communicate over WebSockets. So there's we probably have a couple REST endpoints somewhere. I'm not, they're probably for third parties doing something, but the vast majority of what we do is over the WebSocket. That's for a few reasons, like just speed. We can do some caching on the server for the lifetime of that socket connection, make lookups fast. Like one thing that we were just thinking through the other day, actually, is if you were to look at the WebSocket messages being sent, you might look and say, wow, that's a lot of requests going through, right? But they're not really requests, right? Because you're really just paying back and forth. Like we check ownership, we check to see what your status of a specific collectible is. And that may happen 100 times, but it's all cache. So you're just basically asking the server to tell you what it's already got in memory if something is essentially true or false. So the speed there is not the concern. The number of requests is not the concern because the socket's already open. So all that really does is save the case of, like, imagine, we have a let's call it like a 5 megabyte payload of data that we can make the server hold rather than shipping it over in JSON to the client and then having like in one big swoop and then having them kind of keep checking their own stuff. This way we just offload that work, make the server do some extra work.
That's very interesting. That's the first time I'm hearing that architecture. Is this called something like getting rid of REST all across and just focusing on WebSockets and having in-memory data? Have you used this somewhere in the past? Is there a reason you architected it this way?
I mean, we definitely have used like WebSockets, Phoenix channels, even back to Solana Spaces, a lot of the real-time aspects. I don't know exactly when we started doing it. One thing it relates to is essentially the whole Sybil discussion, because we realized this was a barrier to entry in the early days. People figured it out. But it definitely caused a little blip in the roadmap of some of the people trying to do these things. So yeah, it's essentially, in some ways we use it almost like REST in that kind of back and forth style, but it also gives us the ability to do much more when we want to.
Makes sense.
And this is actually pretty cool. Yeah, like Fakir, this is the first time I'm hearing of such an architecture. So essentially, if I understood it correctly, you have the stream of messages going between the WebSocket channels, and then you receive the messages and you process that. So in essence, you have like every individual client is a subscriber to these topics, and then they act upon every message they get. So a lot of the heavy lifting is also at the front end, or like these messages are already...
I'd say it's a hybrid. I'd say it's more of we do have aspects where the client is listening for certain, essentially like pub sub type events and handling things on their client side. But then we do use it also just as essentially REST that's over a WebSocket. So, we're asking for your vault data, we're getting back your vault data. And the client could decide to do things with that. There's certain aspects of it where it's kind of up to the client, like how far down the road they want to go. If they would like to persist certain data, and if they would like to granularly update data client side, there's options to go down that road. They potentially could not do that and just refetch data over the same channel if that's easier. I guess it just depends on the use case. And we have a lot of probably examples of each use case. So we've got like certain ones that were like basically subscribing and reacting, and then others where it is more just like fetch, paginate, things like that.
Very interesting. Yeah, it's the first time I'm hearing this architecture. I'm going to try it in a project. Cool. That's all the questions I had. Sheikh.
Yeah, I think we have pretty much covered most of it. A lot of developers are going to be listening into this podcast. So are you hiring for any open roles? If yes, like what type of, dev or what type of skill sets are you looking for?
We're not actively at the moment. We've got quite a few people right now who are doing a great job, and I think we've got plenty to go on right now. But in terms of the things that we would be if we were actively, it would definitely be, around that like Rust specific and like potentially interfacing with Elixir, that sort of thing. Anybody who has extensive database experience, I think those are really like the skills that can help in an area like what we're doing. Query optimization and just understanding the complexity of the schema and how, like, knowing off the bat, like what would make an efficient query and what would make it inefficient. And then digging in and analyzing and fine tuning those things. Those are all very relevant skill sets for us.
Awesome.
Cool. That's all the questions we had. Sheikh, do you have anything else?
Yeah, I think we covered most of it. Thank you so much for joining us, Joe. It's really fantastic hearing the stories from the trenches. This is part of what the crypto Twitter doesn't get to see, what it really takes to run a well-oiled machinery running. I mean, they just say devs do something. There's actually a ton of things that devs are doing behind the scenes. So thank you so much for joining us and sharing the story of Drip with us.
Excellent. Thank you guys so much.
Thank you. Have a good day. Bye-bye.
Take care.
Have a good day. Thank you, Jared.